Hello everyone, it's October the 2nd. Well, we're doing the new interface, so here it is. We can actually see the question name, the number, the acceptance rate, and the difficulty before we even start. So we know it's a hard question today. All right, let's go for it. All right, let's see. Dungeon game. Oh, the demons had captured the princess and imprisoned her in the bottom right corner of a dungeon. Okay, bottom right corner. The dungeon consists of n by n rooms laid out in a 2D grid. Our valiant knight was initially positioned in the top left room and must fight his way through dungeon to rescue the princess. The knight has an initial health point represented by a positive integer. If at any point his health point drops to 0 or below, he dies immediately. Some of the rooms are guarded by demons, represented by negative integers, so the knight loses health upon entering these rooms. Other rooms are either empty, represented by 0, or contain magic orbs that increase the knight's health, represented by positive integers. To reach the princess as quickly as possible, the knight decides to move only right or down in each step. Return the knight's minimum initial health so that he can rescue the princess. Yeah, it feels Diablo to me, right? We were talking about Diablo earlier. Note that any room can contain threats or power-ups, even the first room the knight enters, and the bottom right room where the princess is imprisoned. Okay, so in the first example, the minimum health is 7. If it goes right, that's -5, -2, -1, and -4. So if I have 7, then I can sustain. Hold on, 7, 5, 2, 5, 6. That'll be 1. At the end, it'll be 1, right? So this path, what about this path? -7. Oh, that requires 8. Ah, I see. This one requires 8. Ooh, interesting question. So, what's the size? 200. 200 by 200. Okay. I can find a path. I mean, the minimum path, because it's going downward, right? Where the minimum number of steps is the same. That's not a problem. So we can go through all types of, right? And then, because we cannot find the, let's say, the minimum, right? Let's say like if we go this path, at the end we have a large positive number, but that's not going to work because initially we're going to lose health, right? So what do we do? What do we do? I mean, apparently this has to be some sort of dynamic programming, right? So let's say we end up at a certain position, right? To reach the last point, and if the last point is negative, so the minimum health must be larger than, right? In this case, because the last one is -5, so the minimum, like when we're at here or here, must be 6, right? So I'd say this will be 6. This will be 6. And then this is a power up, which means the minimum we need for this position and this position will be 5, right? So we have 5 here, and we have 5 here. So if we have 5 here, this is 3, which means the minimum the need from here is 2. And it's 5 here, that means the minimum at here and here must be 15, right? So 15 or 15. And then if it's 15 here, and then we have another one, the minimum required is 2. So we pick 2. And then it's a -3, so minimum will be 5 here. And this will be 15, so the minimum here will be 20. and then we pick the 5. So the minimum to enter this will be 7. Okay, so that's one route. Now we pick another route. Like we pick this route 6, right? So it's 30. Oh, which means the minimum required for this and this is 1, right? Because the minimum is 1. So minimum is 1. So if we enter here is 1, earlier we enter here is what? It's 15. So we actually pick 1. Okay, so now we pick 1. And then if it's 1, this must be 11. And this must be 11. So that's still not good. There's 1 here, that's still 1. And 1 coming, so coming here is 1. So go back is also 1. So to niche here, when it's 6, that will be 8. Right, 8 is not smaller than 7. So what we're saying is we go the other way around, right? We go from bottom right to top left. And as we go, at each step, it's going to be, it can be DFS, right? It doesn't really matter. I think we go through every single 100 times 100, 100 times 100, 10,000. Well, 200 times 200, 40,000 should be fine. So if we DFS the entire thing, and then we just keep recording the minimum that each position needs, and then we, at the end, we try to check this. Would that be sufficient? The minimum we need to go to the next one, right? The minimum we need to go to the next one. And then from there, if it's, and when we check, right? If it's smaller, we keep going. If it's larger, then we don't keep going. Let's give it a shot. Let's give it a shot. See how this works. Right? Pull this out. Oops. Okay. Let's delete everything. Now what? Now we are going to copy and paste this. All right. So we have a dungeon and we need a DFS, right? So we need a score. No, HP, part HP. HP, we can have n equals len dungeon, and len dungeon 0, all right? And HP equals to, we're gonna go, actually no one needs to go maximum because it's minus 1,000. Hey, I just do maximum, it's easier. So import math, right? So I do math.inf times n full underscore in range m. So we create a new array that will record all the health points, the minimum health points at each spot. And then we're gonna go DFS, right? So we have I, J, and that should be it. And then we don't return anything. So we're gonna start. At a position, right? I'm gonna start at a position. Now the position is going to be, it should be, this is the starting position, right? And if it's a starting position, what my current life should be I need to pass in another thing, I think. So I'm entering, so in this position, I need to have 6 health, right? 6 health, so 6 health. So I say 6 health, we're going to this one. How much do I need? And it's 1, so in this one, I only need 5, right? So I need to pass in a value, but can I just check this? I can, but I don't think it's necessary. So I pass in my health, right? And then, yeah, so this actually passing the health. So at this one, the health should be 1, right? So I enter this with 1 health, and I see as -5. That means I need to, when I enter, it has to have 6. And now I go to the next one, which means we're talking about is after we finish this cell, it has to be 6. So what's the entering? So we have to have health, right? In the in. So this health is after I finish ij. That's the health, and we're gonna record what is our beginning, right? All right. So we have the current health, and we have ij, and what we're gonna do? We're gonna check, right? We're gonna check. We're gonna say if, right? If dungeon ij is smaller than 0, then I am going to minus that value. That's the starting point. If the dungeon is positive, then I'm going to minus that value, which is the same, right? So I always going to minus a value, and so the start, so the enter health, right? Enter initial health. Init health shall be the current health minus dungeon ij, right? Minus dungeon ij. And if dungeon ij is a negative value, it's going to be positive. So if it's a positive value, it's going to be, and then we're going to say the minimum has to be 1. Right? That's the enter one. So do we go, no, that's not min, that's max. So I'm going to, if the dungeon is a really large value, then I'm going to be negative, but we're going to take 1, right? So that's the initial health. And then when I compare, when I see my next step, right? So I have 2 steps. I can either go up or go left. So I say go up. Actually, no. Let's say for next I, next j in this and this, right? So I have 2 different possibilities. One is going to be go up, I minus 1 and j, and also go left is I j minus 1, right? Yeah, if 0 smaller or equal to and I smaller to, because I'm going up. I think it just larger than 0 should be sufficient, and nj is larger than 0, right? Because we're starting from, yeah, we always go up and go left, right? Yeah, always go up or go left, go up or go left, and then that should be the check. So if that's the case, then we're gonna see if if HP. Oh, I should call it initial HP. That's fine. I just say if HP NINJ, right? If that is larger than initial health, then we say HP NINJ will equal to initial health, and when DFS, so that's the right way to go. So we're going to DFS NINJ initial health, right? That's initial health. So we go to the previous one, and then that will be the after health. So that's that. And if this one's already smaller or equal to initial health, that means we either visit already, so we don't have to do it again. So we go through this, right, until we reach the end. And there's nothing we need to do, right? There's nothing we need to do. Then we just run this DFS, and at the end, we're going to return HP 0, 0. That should be the smallest HP. Not sure, but try to check. Feel like there might be some trick that I miss. Let's first see if this one passed. So 2 test cases, and make sure both pass. Oh, what did you do, man? Okay. So we have here is dungeon. This is going to be calculate minimum HP dungeon. Rest is infinite. How? What did I do wrong? HP is this, and I reset the HP, and I go to the next one. Are you saying I'm not finding the starting point? Hold on. Did I do wrong? Print N9NJ. Let's see, where do we go? Oh! I didn't call the function. DFS. We start with n minus 1, right? And starting has to be 1. Starting point is 1, which means HP. Oh, hold on. Starting point. I didn't use a starting point. Huh. Interesting. Would a starting point be anything other than 1? Let's just say starting point is 1. So n minus 1, right? And then n minus 1 equals 1. That's the starting point, is 1. And then we always check the previous. This is 5. Oh, that is not correct. How is 5 possible? Initial health, right, is before we start, and then health is after. And then with the after minus when we start. So initial start would be 1. And then, yeah, after that, it's fine. No matter what we have, doesn't matter. The minimum, right? Minimum, we enter a cell. Minimum is 1. So like if a cell is positive, then we just minimum is 1. If a cell is negative, then is the health minus this. So it will be a positive value. Oh, I think I need to minus this. Yeah, that's fine. The health minus this. Interesting. Let's print ij and initial health. See what happens. So at 2, 2, right? So 2, 2 is here. Initial health needs to be 6, right? Which is correct. And then next one I go 1, 2. So 0, 1, 1, 2 will go here. So initial health is going to be 5 because 6 minus 1 is 5, right? So next one 0, 2. Initial health is 5. Okay, so 5 is 3, which means initial health will be to 2. So now we go to 0, 1, right? And then that one calculation health is 5. That's right. 7, 0, 0 is 7. Right? 0, 0 is 7. So 0, 0, we calculate. So the initial health is 7. Then you did not upgrade the initial health? Huh. I think the logic needs to change a little bit. So this is the after health. So HP represents the initial health, right? So the initial health is So what I provide is after, right? The health is after I finish the cell, right? So that's the initial health. I think I labeled it wrong. So initial health is this, so whatever value it is, right? And then I need to go to the previous one, right? We go to the previous one. So if I go to the previous one, I have, this is the after health, and then I compute the initial health. And I say, I think that's here. I think it's to say if HP ij, right, is larger than initial health, then we'll say this has not been visited before or it's worth visiting. Then I try to go, right? How do we go? Then first say HP ij is going to be initial health, and then we choose this. We go DFS like that, like that. No, this one becomes infinite. How? IJ initial health. Oh, HP is larger. Yeah. Oh, because I do this. There we go. And now we are good. Okay. So we don't say it initially. Okay. Let's try this one. We run the code first. Figure out a new test case. Yeah, let's just submit it. It's a difficult question. So if we failed, then I think it's okay that we try it again. Oh, that's why it's difficult. I think we timed out. Yeah, either wrong or we timed out. Okay. Yeah, it's a naive solution and we timed out. All test cases passed, but took too long. We already we're not taking all the steps, right? Like some steps and we passed all the test cases, just a little bit too long. And just a little bit too long. All right, let's see. Let's see. All right, so we have after health or passing, so we know the initial health. This is deterministic. And then we go here and we go here, all right? And then this is determined to be I don't know. Bless you. Are we hitting every single thing? And we're not returning anything, right? That's the thing. Right? You can't even. Yeah, this is like our. Yeah, I checked. Right, I checked to see if the current position and our initial health, if current health is larger, that means it's worth visiting. And I visit it, then I go for both. I will go for both directions. Like if I visit a cell, then maybe you say df instead of df, maybe bfs. Would that be how do I do bfs? So in here is I'm gonna go this one, go this, and I know also the health. And for this, I can go here. I can go here, right? And then for this, I can go here and here as well. But as we go here, we can check to see the current, like the previous one. And we pick the one that with the, I'm gonna hit it once. Is that what it means by hitting every single thing once, one time? Is this not hitting it once? Like I go this one first, right? And then we come back. There's no way to go, right? So we'll come back. Let me print it out. Let me print it out. See where we went. Print ij. Let's print health as well. I don't think we repeat. I mean, we did hit 0, 1 again, right? Well, from 0, 1. So the first time we hit 0, 1, we have 2. So 0, 0, we have 5. So 0, 1, we have 2. When we enter, we have 2. And then I think we do this as 5. The second time, and then 0, 0, and we're done. And then we go 1, 1. It's here. So that's the, we'll go here, here, and this is on one path. So we go here, 1, 1, right? 1, 1. And then we go 0, 1. It's 15. And then we check. So we immediately, we don't do 0, 1 anymore. And we do the 1, 0, right? See, we do 1, 0. 1, 0 is done. We go to 0, 0. And it's no good. Right? Or the 0, 0 is no good.